So this year I did a little Bluetooth costume piece, which I brought to the anniversary party. So some of y'all might have seen me with it. Um, I don't really know if it's technically a bracer or a torque because a bracer fits on your forearm, where a torque is a usually a piece of metal that like wraps around your arm and it wraps around your forearm. So the debates can be made. um, All right, so what is it? It's an LED costume piece. It sits on your forearm. And what it's doing, so if you saw it at the party, you may have seen it flashing and just thought it was random. Oh no, it's way more complicated than that. So it's actually scanning for nearby Bluetooth devices. And what it's specifically doing is it's taking the 10 with the strongest signal return, and then based on the relative signal strengths, it's positioning them on the bracer, and it's trying to do some level of transitions between them. There's also a second copy. So my date Anne also had one of these on her arm. And so the bar that you see at the bottom, that's that pinkish color, they actually basically send out a Bluetooth advertisement with a special tag. And when it sees that, then it uses that to basically build a signal strength graph of a bar of the basically the attempting to be the relative distance between the two of us. So as we step away from each other at the party, then that bar goes away. As we approach each other at the party, then the bar gets full again. Um, so just a quick demo of this. Hopefully this works fairly well. So it's flashing, it's doing things. I walk away from it, so you'll see that at the bottom, the lights start going away. And then as I walk back up, then the lights start coming back on. Um, so like I said, it advertises a Bluetooth advertisement. A little Easter egg. Impossible to find at the party because of the sheer number of Bluetooth devices. But it actually is chirping a name of its name is a specific date string, and it's the date that we got engaged. So I thought it was super cute. So a couple photos of internals and whatnot. So yeah, breadboard stuff beforehand. Came out fairly clean. On the right is actually put together. So the top two buttons act as brightness increase and decrease. The switch basically sends a log message that the switch was switched. There was intent for there to be more than one animation mode, and so the switch would allow you to switch between the two modes. It doesn't have that, so it just sends a little console log saying, "Hey, I switched that switch," and then it does nothing with it. So made heavy use of 3D printing for the actual bracer part. Um, it is done with a resin 3D printer. So if you haven't seen those, if you've seen normal 3D printers, FDM style, you've seen where it has like that print head that kind of comes down and then it draws it up like basically layer by layer. And it's really just a really fancy hot glue gun. Just putting out plastic because the plastic's on a spool. It shoves the plastic through a hot end, and it basically deposits a string of material to build what you want. Resin works a little bit different in that you have a vat of resin and it's like epoxy, except that it cures with UV light, not with if there's no part A, part B. Instead, it cures with in the presence of ultraviolet light. And so at the very bottom of that vat is a screen with a UV light emitter behind it, and it just turns on pixels on and off on that screen to create a mask. And so it basically exposes the entire layer at once. And so it actually has a very interesting print property of normal FDM printers. The time to print is dependent on the volume, where resin printers, it's entirely dependent on the height of the tallest object on your print bed. Otherwise, because it's doing the entire layer simultaneously. And so with that, you actually have to cure it afterwards. So that's what the picture on the right is that it comes out and it's pretty firm, but it's a little tacky. Like it's a little, it's a little sticky because the resin's not fully cured, just enough to keep it like in its form. And then you expose it to a lot more UV light, and then it hardens it up. So with that, I wanted this thing to. I was like, I kind of wanted to have like uniform color because normally when you use these little LED light strips, you have like the white pixel, like casing, you have all the electronic circuitry, having different colors and whatnot. And so I was like, hey, I think it would look really nice if this was like a uniform black. But if you want to do that, the easiest way probably would be use spray paint, right? Except that you have all these little lights that actually need to be exposed. And so we actually pulled in the CNC laser for this project as well, so that way I could create 120 stickers, 3 millimeter stickers to put onto each and every one of those lights, spray paint the whole thing, and then use the tweezers to pull them all back off again. So very labor intensive. So yeah, I think how it's made always ends being a little interesting. So it used two different 3D printers. So there is a little kind of wart that we wore on our shoulders. I was able to hide it in my shirt and did not have a sleeve to hide it in. But that's where that circuit board and actually where the battery sits. And so that was just done on a normal FDM printer because it's fast and ridiculously cheap in terms of materials. Resin's a lot more expensive as a consumable. Like I said, the laser actually got pulled in just to help make those little masks for the paint job. So I want to point out, I think this was very entertaining and just how poorly it kept its form. That's supposed to be the spiral, right? So normally resin printers, what they're really good for is they're really precise in what they can build. And so you have really tight tolerances. The prints are just absolutely beautiful. That's why people use it for like miniatures and stuff. But they tend to be very brittle materials. And so you drop that miniature a couple feet and it will just shatter like glass. You can apparently, I found this out, you can get elastic resin. And if you use 100% elastic resin, it's actually way too elastic and it does not hold its form particularly well. So the actual mixture that we used for the party was a 20% elastic resin, and then the rest of it was the normal brittle stuff. And so that gave it enough elasticity to be able to be wrapped onto our arms and kind of hold onto our arms without shattering from that flexing. The other thing that I thought was really interesting with this project is I actually did almost all of the software in the simulator before I actually moved on to real hardware, which is really nice because like if you're pushing the code over a serial line, it can take upwards of a minute to flash the device. Like it's not super fast operation. So especially once you start moving on to look and feel and you're like, oh, like how many lights should be represented? What colors should be the colors that are available? Those are just like minor changes and you're trying to look for a look and feel. And so doing that to hardware is a very slow iteration process where it takes less than 5 seconds to hitting compile and getting it running inside the simulator is like 5 seconds. Yeah, so like I said, you can basically build it out. The simulator is really cool because you can actually have like all the lights and whatnot on there. It's running your entire firmware for real. The only thing that was the caveat is it does not have any form of Bluetooth simulated. And so basically I just had a compile time flag that said, hey, if you're going to the simulator, here's a mini little snippet of a program that will generate fake Bluetooth data. Otherwise, the simulator is representing the whole thing, which I think is really, really cool from a development and hobby perspective. And also, if you're like, oh, like I want to play with some of the stuff, but I don't know what to buy, or I don't want to buy things, or I don't want to like break the thing I bought, the simulator's free, guys. And I've got a link at the end for where you can kind of find it to play with. So I just think that's super, super cool. So yeah, some fun facts associated with the project. I originally was going to do a different project. Y'all don't get to see that now because I got bullied into doing this one. I got several people who were like, hey, I bet you have some really cool costume piece for this party. And I was like, I was just going to dress nice. That's all I was going to do. So the actual sit down, design something, buy all the stuff, and show up to the party was about 3 weeks. This was a very fast turn project. I always want to shout out, all the code is actually done in Rust, which I just think is cool, especially in microcontroller land. The microcontroller used is an ESP32. I love them. They're really cheap. You can get like a nice dev board for $15 to $20. And then if you're actually buying it from like at a component level where you're gonna like get it soldered into something, they're like $3.50. Like they're super cheap. But it's dual core, 240 megahertz processor, decent bit of RAM, like 16 megs of flash these days. And it runs an entire real-time operating system, which lets you do really nice things for like in Rust. You have the full standard library. You can just create a socket to like some arbitrary like port somewhere, or you can open a file as if it's like a file system. So I just think that's really cool from a programming standpoint. You don't have to program really as if it's a microcontroller. You can program as if it's running on an operating system. It just has access to microcontroller things like GPIO, Bluetooth, whatever. And then I misestimated the battery life. So I, based on the spec sheet of the lights, was like, oh, this will probably draw somewhere upwards of an amp. And so if I do a 5,000 milliamp hour battery, I get about 5 hours. That's about long enough for the party. Sounds great. Yeah, it draws like 200 milliamps. So it's like 20, 25 hours. We got through the entire party and it was still like over halfway full on the batteries. It's yeah, really overdid on the battery. So some problems with this is I did not really account for how busy the Bluetooth spectrum would be. Like one should imagine that a party with 400 people probably has a lot of Bluetooth devices running around. Didn't really account for that. And then mine ended up being kind of loose because I printed two sizes, but by the time I was doing the actual like final printing of the things, it was like Monday, Tuesday, and that's a 10-hour print for that, for the arm piece. So you can't keep iterating when you only have a couple days left and you're like, I need to paint this thing. And the electronic box was kind of bulky, it was kind of scratchy. Didn't help that the battery was way bigger capacity wise than it needed to have been. I would have liked some better animation schemes. Like I said, it kind of ended up looking very random. But we probably could have designed it a little bit better so that way like it wasn't as random and maybe you could bias like what the animation does by like blocking it off from certain like directions of the room, or your device gets really close and be like, oh hey, there's a really close device. Let me make sure I show him so that way you can interact with it by putting like your Fitbit really close to my electronics. And then probably needed more than 20% of the elastic resin in there because Anne's broke at the end of the party, but whatever. And so when I was speaking of the Bluetooth, so the left side is my test environment. This is what I was seeing at home. This is the party. There is a lot more Bluetooth traffic over here. So it's just constantly flickering between which devices it's going to show. So it's just, basically flickering constantly. And so, yeah, that's it. I am open to questions, but I know that I took up a decent bit of time, so you guys can just cut me off. Here's some QR codes real quick for links if you are curious. All the code is on GitHub. There's even a tagged release that has the firmware or a version of the firmware that can run in the simulator. And then on the right is a link to the actual simulator itself with instructions of how to load the firmware into it. But yeah, that's a thing. That's the thing I made, and I even have it flashing on my desk right now because why not?